Hello, my friends. In this video, we're going to be taking a look at Log04, which is a sample from Middle Bronze Age Greece. It is a early Greek sample. It's a Indo-European sample. This individual is female. She carries mitochondrial lineage J1C, and this is what she scores with the Davidsky's global model with G25. So she's scoring a mixture of Anatolian Neolithic farmer plus Yamna. She doesn't score any Western hunter-gatherer or any of the additional components that are present on this calculator, so she only scores the Anatolian farmer plus Yamna. And in terms of the closest modern populations to her, it is Greeks, it is Pomaks, I think, are Bulgarians, or is it Turkish people from Bulgaria? I think it's Turkish people from Bulgaria. It's Torbesi, whatever that is. Greeks, Turkish from Macedonia, uh, Italians, Albanians, Gagauz, which are Turkic people from Romania. So she's close to various Balkan people. She's quite northern. Um, I'm pretty sure Thessaly also is northern Greece as well. So she's a bit more northern than Greeks are in general. But let's go ahead and look at what she scores with my trait predictor. My trait predictor does not predict mitochondrial DNA. It only predicts Y DNA, so we don't see a Y DNA prediction for her. She's a female. But let's start with Nashakot calculator results. And as you can see, she's scoring brown eye color at 80.9% likelihood. So she's quite dark. She's scoring dark brown hair at 97% likelihood. So she definitely has very dark hair color as well. And she's scoring olive or Mediterranean skin tone at 89% likelihood odds. Regarding hair texture, she's scoring curly hair at 53% odds. Regarding nose shape, she's scoring, looks like intermediate between Greek and snub-shaped nose. But if I was doing one of my videos where I collect samples and I collect data on the samples, I would log this sample as scoring snub-shaped nose, because snub-shaped nose in this case is over 50%. But let's look at the sample's genotype. So she doesn't have any light color variants in these variations of HERC2, which is really surprising. That's really surprising for somebody who's a West Eurasian, for somebody who's a European as well. Europeans in general, that's a very exotic genotype for a European, actually. And she doesn't have BEH3, no BEH2, no BEH1. So yeah, she's very dark, certainly very dark. And that reflects on the prediction for skin tone, for eye color, for hair color. That's why, for example, if you look at the prediction for, where is it, for YSEC, YSEC predicts her to have very pale skin. And that's completely impossible. If you have her genotype in HERC2 and OCA2, it's impossible to have very pale skin with this genotype in HERC2, OCA2. Completely impossible. And it also predicts her to have red hair, which is sort of possible, but not really. Also not really with her genotypes, because she only has one variation in MC1R where she's got two variants for red hair, which is not enough considering how dark she is. She's also predicted to have so she's predicted to have dark hair and dark eyes and dark, relative to Europeans, dark skin as well, because olive skin tone relative to Europeans, that is dark skin. Relative to everybody else in the world, that is quite light, but for European standards, olive skin is quite dark. So this is why I'm substantiating my claim. This is why the prediction is the way it is. This is why it is different from YSEC prediction, because YSEC doesn't take into account the effect that HERC2 and OCA2 plays on the pigmentation of skin and hair. She does have two light color variants in all the SLC 45A2 and 24A5 variations, so that's a part of the reason why she scores olive skin, for example, and not light brown or dark brown, and why she scores dark brown hair and not black hair, and why she scores brown eyes instead of dark brown eyes with her genotype. That's a part of the reason why she scores the way she does. So she still has a European coloring despite having this exotic genotype in HERC2, OCA2. She doesn't have hunter-gatherer, red hair, blue eyes, and pale skin variants in IRF4. and she doesn't carry the Afontavagara 3 blonde hair variant and Kitoji either. Okay, actually I would be quite interested to see what she scores with Snipper 3. Let's look at what she scores for eye color. Well, that's useless. Eye color, she's gonna score brown. That's very obvious. But let's look at what she scores for hair color with Snipper 3. That's gonna be very interesting to see what she scores for hair color with Snipper 3. It might be red, because she does have the 2 variants for ginger hair in MC1R. So let's find the variants here. Yes, it is this variation. And here she's got AA genotype, and she's got the genotype that is very much predictive of red hair, as you can see. The A allele has a frequency of 50% among the red hair population. Brown hair is 6%, blonde hair is 7%, red hair is 50%. So it's and black hair 0%. So this is something that's making her very much likely to score red hair, this genotype right here. But let's see what she scores. And despite that, she's actually still scoring brown hair with Snipper 3. Despite this genotype, she's still scoring brown hair with Snipper 3. So even Snipper 3, even though it doesn't have that many, how many does it have? It has this genotype in HERC2 and this genotype in HERC2. So Snipper 3 does have some genotypes in HERC2, but not as many as my tool does. So because my tool has way more genotypes in HERC2 that play a role in the calculation of hair color, because of that, my tool gives her a much lower percentage likelihood of red hair. But Snipper 3 has only 2 variations that play a role, and because of that, Snipper 3, the likelihood of red hair here is a little bit higher. But Snipper 3 still predicts to have brown hair. So YSEG prediction for red hair is not entirely accurate. Alright. Now let's look at phenotype oracle, and let's see what phenotypes are predicted for her. So the closest phenotype that's predicted for her is this, which is an alpinate phenotype, followed by this, which is a denatid phenotype, followed by this, which is a Volgate phenotype. And the closest mixtures, let me zoom out so you can see the female versions. Yeah, let me zoom out. So the closest mixture is a mixture of this, which I don't even know what to call it. It's like I guess Sardinian or something, plus chordate phenotype, right? So what I did is I took the female version of this phenotype on the top, plus the female version of the phenotype on the bottom. By the way, look at the distance. The distance to this mixture is 0.589, and the distance to closest phenotype alpinate is 0.6. So this mixture is much closer to her than the closest phenotype. So what I did with this mixture is I took I snapped the woman on top, I snapped the woman on bottom, and I went on face morph, and I morphed them two together, and that's what I got here. So the predicted phenotype for this individual is something like this. Now, I do a little bit disagree with this, because it looks like face morph does its own thing. It kind of lightens the eye color in every case. Whenever you upload a picture here, they lighten the eye color. I don't know why they do that, but they did lighten the eye color in this case as well. So just imagine this phenotype, but with brown eyes instead of whatever this is. All right. Let's turn back to biomarkers. We're gonna look at that. Looks like she scores very low levels of vitamin D. That's very interesting. Let's look up vitamin D in monogenic traits. So there's these 5 variations here that were found, and looks like she's got the risk icons for all of them. So she's got all these 5 variations, and in all of them she's got a genotype that leads to lower levels of vitamin D. Right, and because of that, she scores lower level of vitamin D. She's predicted to have higher level of LDL cholesterol and lower level HDL cholesterol. That is a bad predisposition, but it's not horrible because it's kind of close to the average. She's got a lower level of glucose, which is good. Oh no, that's not lower. That's very high level of glucose, which is bad. I misread. She's got a higher level of hemoglobin. Okay. She's got slightly higher blood pressure, because the average with my tool is 170 and 120. So she's got slightly above average blood pressure, but blood pressure is not something I don't really in my videos, videos that I make on like ethnicities, I generally don't include blood pressure among the results, because this is something that's, even though it is genetic, it is also environmental. It's also very much determined by the environment and what you eat, and even your diet and stuff like that, and how much you exercise. So it's not something that I include in my videos. I don't find it to be entirely genetic. She's got a lower level of iron in the blood, so she doesn't have any hemochromatosis variants. She's got a lower level of sex hormone binding globulin in blood. She's got a average level of red blood cell count in blood. That's pretty good. She's got average number of telomere length, so that's pretty good. And she's got average or maybe slightly above average height. Pretty cool. All right, let's see what can we find anything else that's interesting here. For blood type, she's scoring type A. Wow, that's quite interesting, because when I was doing my videos on Mycenaeans, I noticed that 5 out of 6 samples scored blood type A. It looks like blood type A is a pretty common blood type for the Greeks. So, is this something that I'm going to continue seeing with the Greeks? I'm going to make videos on Minoans. Is this something that I'm going to continue seeing with Greeks, that blood type A is going to be common? I don't know. Let's find out. Let's see. Polygenic risk scores. Alright, she scores lower for kidney stones. She scores lower for erythema nodosum. She doesn't have any risk variants for hemoglobin E disease. No risk variants found in the file. She's got average odds for migraine. She's got average odds for lupus. She's got very low odds for gout. Look at that, 0.15. That is probably the lowest odds for gout you can score with my tool. That is probably the lowest you can score. And also, I did notice that Europeans tend to score very low for odds of gout. She's got average odds for eczema. She's got average odds for exfoliation glaucoma, average for pigmented glaucoma, average for open-angle glaucoma, and average for primary congenital glaucoma. She's got average odds for polycystic ovary syndrome. She's got high odds for cataracts, average odds for age-related macular degeneration, slightly below average odds for rheumatoid arthritis, which is very interesting because that's also a European kind of condition. She's got a average odds of Tourette's. She's got a average odds of epilepsy. She's got a average odds of asthma. She's got very high odds of leukemia, which is also a European condition. It's not entirely a European condition, but it's much more prevalent in Europeans than other ethnicities. She's got below average odds of vitiligo. She's got high odds of myopia. She's got low odds of corneal astigmatism. She's got low odds of primary biliary cirrhosis. She's got low odds of stroke. She's got high odds of male pattern hair loss. That's very interesting. So, regarding male pattern hair loss, which is something that's very common in Greeks, I would say today, very much the stereotype of a balding Greek man or Italian or a Jew, balding Jewish, Greek, Italian, whatever. Male pattern hair loss is very prevalent in these populations today. So, not surprising that she scores this. Below averages for atrial fibrillation. Below averages for deep vein thrombosis, which is a cardiovascular condition when your blood clots up in your legs or something. She's got lower odds of cardiovascular issues. And for ADHD, she's scoring lower for odds of ADHD. Looks like she doesn't have any risk variants for that in TAC1, which is good. For depression, she's scoring high for odds of depression, which is very interesting, and she has got short form 5-HTTLPR. She's got this genotype, which is very interesting as well. She's got some risk variants for depression in HTR2A, which I would need to research more about to really find out more about them, because I don't remember what they do. But it's very easy to research this stuff. Like, you just look at this on the panel and you copy and you Google it, and you can find out more about them. So this is really easy to research. If you found this in your result, if you bought my TraitPredictor and you analyzed yourself using it, you can easily do this research yourself. Bipolar type 1, she's scoring below average odds for that. Schizophrenia, she's scoring average odds for that. Diabetes, she's scoring below average odds for that. Type 1 diabetes. Type 2 diabetes is scoring very high odds. Wow, very high odds for type 2 diabetes. That's very interesting. Okay. Very high odds for type 2. I just noticed that I included FTO here in type 2 diabetes. That's very interesting. That's very smart that I did that, including FTO in type 2 diabetes. Intelligent design, including FTO gene in type 2 diabetes panel. Okay, she's got average score for Alzheimer's. I'm gonna explain what I said here because I feel like that's gonna go over so many people's heads. FTO is a gene that has to do with your predisposition to obesity and predisposition to gaining weight and how your body handles certain nutrients and food. So obesity is very much predictive of type 2 diabetes. Obesity and insulin resistance is very much predictive of type 2 diabetes. So FTO is usually not included in any of the panels for type 2 diabetes in other tools that are trying to predict type 2 diabetes risk score. So what I did here is I included FTO, as you can see here, in the prediction panel for type 2 diabetes, which I think was really clever because it does correlate with type 2 diabetes risk. But I don't know. She's got average score for Alzheimer's. She's got lower score for multiple sclerosis, so she doesn't carry any of the DRB1 risk variants for that. One risk variant for breast cancer. Let's see, where is that? We're gonna find out where that is. Looks like that is BRCA2. Okay, she's got lower odds for prostate cancer, so probably lower odds for epithelial cancers in general. Let's look at that. So yeah, lower odds for epithelial cancers, as you can see here. High odds for glioma, so that is all of these stuff. And lower odds for thyroid cancer. She doesn't have any JAK2 risk variants out of 10 total found in the file, so she doesn't have any predisposition to polycythemia vera. And for testicular cancer, looks like she's got heterozygous genotype here, actually. That's really good. So she's quite protected from testicular cancer, at least compared to Europeans. Compared to, like, say, Africans. Actually, it's just Africans, right? Because Africans are the ones who don't carry the testicular cancer risk variant in kilo G. So compared to Africans, she's cooked. But compared to Europeans, she's doing quite good. Because Europeans tend to have homozygous risk genotype in kilo G for testicular cancer. Let's see what else. Celiac disease, she's got one risk variant for celiac disease, and it's here. Okay, interesting. Why does it say 1 but it says 2 here? Interesting. Once again, this is something that you can research. You can find this stuff in your file. If you see something like this that's confusing like that a little bit, you can look this up in your file and see what your genotype is. And whether you have 1 or 2 risk variants, that's something that's very easy to clear up because I do print out your genotype here on the page. I mean, not the genotype, but I do print out the variation where the risk variants were found. So it's very easy to do this research. She's got 3 risk variants for Crohn's disease out of 26, and it looks like none of them are marked as important. She's got 1 risk variant for Parkinson's, which is here. 1 risk variant for basal cell carcinoma. 3 risk variants for porphyria, which is one of them is not common, which is this one. There is a lot of risk variants here that are not common, actually. 7 risk variants for allergies out of 28 total, which is kind of low, so there is a low predisposition to allergies. And we do see another uncommon risk variant for irritable bowel syndrome. And what else? Uncommon risk variant for beta thalassemia. A bunch of uncommon risk variants for familiar thoracic aortic aneurysm. Uncommon risk variant for Hirschsprung, Fabry, Li-Fraumeni. So if you look at this, you would think that she has all of these uncommon risk variants for all of these rare conditions. She's cooked, right? But really, you have to understand that this is probably a matter of file quality, because when you see so many rare risk variants for so many rare conditions, that is a very clear sign, and these are all miscalls. These are all genotyping errors and miscalls, which are very common in these files. Unfortunately, a lot of these files that are on European Nucleotide Archive have much lower quality and higher rate of miscalls than files generated by 23andMe or MyHeritage or Ancestry DNA. So a lot of these are miscalls. In fact, I would say probably all of these conditions that she scores rare variants for, I would say probably all of them are miscalls. This is a miscall. This is a miscall. I don't think a single one of these rare variants she scores is genuine. Let's go ahead and look at what she scores for some of the main page stuff. Some of the monogenic conditions, you could say. She scores intermediate phenotype, intermediate between warrior and warrior phenotype. So that's based on COMT, MAOA, and MAOB genotypes. So all of these genotypes go into the warrior versus warrior prediction. COMT, MAOA, and MAOB enzymes are the ones that have to do with warrior versus warrior phenotype. And there's also genes called COMT, MAOA, and MAOB that are predictive of the behavior of these enzymes in your dopaminergic system. So I included all of these genes in my prediction here, in my predictor. COMT, MAOA, and MAOB are all included here. And based on her genotypes here, she's intermediate between the warrior and the warrior phenotype. She's predicted to have intermediate number of D2 dopamine receptor sites. So that's based on 1, 2, 3. That's based on these variations. So that's 9 SNPs in this case. Based on these 9 SNPs, based on her genotype in these 9 SNPs, she's predicted to have intermediate number of D2 dopamine receptor sites. That is based on her genotypes in DRD2. There's also in my trait predictor included variants in DRD1, DRD3, DRD4, and DRD5. I think DRD5, where is that? DRD5 is here as well. Yes, this is a DRD5 genotype. So she actually also has a variant in DRD5 that is also present in this file as well. It's quite a high coverage file, because I was about to say quality, but that's obviously going to be contradicting something I said previously. But it's quite a high coverage file. There's variants in DRD5 as well. There's pretty much everything that my trait predictor looks for is found in this file. She doesn't have any variants for dwarfism. So you can pause the video perhaps if you want to, because this is way too much stuff to talk about, but you can examine all the stuff that my trait predictor looks for. She's predicted to have a higher odds of autism, and she's predicted to be lactase persistent. She doesn't carry any variants for lactase persistence. Looks like she doesn't carry the variant in LCT either, nor does she carry the European variants in MCM6. So she's definitely lactose intolerant. Looks like she's got a predisposition to an average level of empathy based on 1, 2, 3, 4, 5, 6 SNPs in OXTR. Now these have to do with diabetes. This is hemochromatosis. She doesn't carry any risk variants for hemochromatosis, as we remember. Nor does she have any risk variants for Alzheimer's and APOE. Nor does she have any risk variants for multiple sclerosis in HLA-DRB1. For cardiovascular, we already went over that. For facial morphology panel, looks like she has European genotype and EZAR, which is very interesting, very good. Higher odds of protruding nasal bridge, shorter mid-face length, larger nose size, nose pointing up, and one genotype for thinner eyebrows and one genotype for intermediate eyebrow thickness. Very interesting. She does not have variants for micropenis. Now, one thing I noticed as well is that with 1240K files, micropenis variants are very common. Something like 1 out of maybe 10 or 1 out of 15 samples I've been analyzing with 1240K files carry risk variants for micropenis, which is really high, very high rate. And it looks like these files are very much prone to show a miscall in this particular variation. But it looks like she doesn't carry the variants for micropenis, which is really good. Obviously these are miscalls. Obviously they don't really carry micropenis, because the rate of mutations there, the rate of the micropenis mutation is very, very low. It's something like 1 in 5,000 people in Europeans and East Asians. So it's a very low rate. It doesn't really show up. It shouldn't be 1 out of 10 or 1 out of 15 samples, obviously, as it is in 1240K samples. Let's see what else. I'm going to scroll past all this. She carries 1 risk variant for pain hypersensitivity out of 12 total. And that is actually here. That is in this variation of SCN9A. Very uncommon genotype, leads to lower pain tolerance and rarely OST. Now, this once again, I would say, is probably a miscall as well, because this is very rare. very uncommon. This is probably a genotyping error or a miscall. So once again, this is probably not a genuine genotype. By the way, if you encounter something like this, if you encounter something that's very rare, and you tested with MyHeritage or 23andMe or Ancestry DNA, it's probably not a miscall. In that case, it's probably genuine. But if you look at some of these files generated by 1240K or files that are found in the European Nucleotide Archive, in their case, it is most likely a miscall. It is most likely genotyping error. Alright, let's look at albinism in a typical traits panel. She doesn't carry any risk variants for albinism. Good. No risk variants for cleft lip. No risk variants for Melanesian blonde hair. Actually, she does carry risk variants for cleft lip. She's got a genotype listed 6 times increased risk of cleft lip. Familiar Mediterranean fever. She carries 1 risk variant for familiar Mediterranean fever. Alright. I guess that's pretty common for Greeks to carry a risk variance for that, because familiar Mediterranean fever is a disease that's very prevalent among Greeks. Let's skip over that. For rare diseases and traits panel, let's see. Does she carry any risk variance for any rare diseases? Let's see. Ankylosing spondylitis, 20 times increased risk of ankylosing spondylitis. Alright. But that's not very rare. That's kind of typical. Okay. No, we don't really see any rare conditions. Good. So she doesn't carry any rare variants for any rare conditions. That's pretty good. Okay. She carries 1 variant that's leading to reduced risk of baldness in the AR gene. That's the A allele here is very common in sub-Saharan Africans, very uncommon in Europeans. So it's a little bit interesting that she carries the A allele here. For HIV and AIDS panel, she doesn't carry any protective variants from HIV. And for HLA gene panel, she's predicted to have lower odds of autoimmune disease on the basis of HLA genotypes. Let's check the HLA genotypes actually. Let's see what she scores there. So she has, in HLA-A, all of the genotypes are good. So HLA-A, all genotypes are good. There is a genotype for higher antibody levels, which is a good genotype. HLA-B looks like all of the genotypes are also good. HLA-C looks like all of the genotypes except for this one are good, but this is not a very big contribution to the score, so it's not horrible. And for HLA-D, this is way too much for me to analyze, but it looks like there is one genotype that leads to higher odds of type 1 diabetes, which is kind of bad. There is also a genotype that leads to 7-fold decrease in the risk of type 1 diabetes, which is good. Well, it's not 7-fold decrease, it's just average score, average risk for type 1 diabetes. It's 7-fold decrease relative to the opposite genotype. So that's something you have to take into account. But it is the average score for type 1 diabetes, average risk for type 1 diabetes. And pretty good, yeah. Overall, it's pretty good. Okay, she's predisposed to intermediate homocysteine levels and no risk variants for any muscular dystrophy myopathies. She carries 2 risk variants for adrenoleukodystrophy. Okay, once again, the variants for ADL here are obviously miscalls, genotyping errors. There is no way that somebody carries so many risk variants for so many rare conditions. So obviously these are all risk miscalls and genotyping errors. Colorblindness panel, she carries no risk variants for that, really good. For FTO gene panel, she's predisposed to intermediate odds of obesity. Alright, intermediate or higher actually. Intermediate or higher odds of obesity. For syncope panel, on the basis of 6 SNPs, she's got below averages of syncope. And for biotraits panel, let's see. She's got 1 copy of the hunter-gatherer, so TCL1, and 1 copy of the farmer variant, which is the intermediate ability to process carbs and sugars. Alright, she's got a genotype that leads to more able to detect beta iodine floral fragrance. And we're going to skip the rest. Yeah, so I'm going to skip the rest. So basically, thanks for watching my video until the very end. You can check out the raw DNA file for this sample on my PayHip page. I sell it for maybe, in this case, maybe $4. So you can buy it for $4 in 23andMe format. You can run it through my TraitPredictor. You can run it through some other tools or GED match or whatever, if you're curious to see what it scores on GED match. you can do whatever you want with the raw DNA file. Basically, you have the raw DNA file, you can do whatever you want with it. And I sell it on my PayHip page, so check out the description of the video for the PayHip page link for this raw DNA file. In the description of the video will also be a link to purchase my TraitPredictor executable. The TraitPredictor executable is something that I use to generate these reports that I show to you in my videos, and essentially all my videos I use my TraitPredictor for them, and you can purchase my TraitPredictor for $25 from my itch page where I sell it. So thank you for watching. Make sure you check out the description of the video and leave a like and share if you enjoyed it. Goodbye.